trying to study the things from the lecture notes rather than lecture slide. Okay, so yes, I mean, for the lecture number one, I mean, if you find something that is actually out of the lecture notes, that is in the slide, then you should have to study that also. Okay, so make sure that, I mean, you're not missing out anything. And you know that, I mean, uh, the final exam time, you are going to be have a common questions, common set for the all the sections. So if you're missing out something, if you're not studying something from the earlier, I mean, from the beginning, then I think in the final examination you'll find that there are some questions are missing. So that's why you have to be very very careful, as because there is going to be only one set questions for your final examination. So you have to be very careful that you are not missing out any topic from that your, I mean, from that your lectures. Okay, so how can you see the slides for the lecture one?
Yes, sir.
Yes, sir.
How much?
Yes, sir.
I think 32.
Yes, sir.
Almost. Yesterday, one student was telling many times, 32, 32, 32. Is it? I think, did we cover this memory? Which slides up to which side? This one we have done. Example of the DRAM?
No, sir.
No.
No, sir.
So, I think we have done up to this, right? No? That how memory is storing the
Sir,
instructions.
up to microprocessor, sir.
Microprocessor.
Slide 25, sir.
35.
Uh,
What are you doing?
25, sir.
One is
25, sir. 25.
up to this.
Yes, sir.
I see. I see. But section F, with them actually I have done up. Okay. So we are going to be start from the slide number 26 today. So here we are talking about that the instruction cycle for that the processor actually, and I mean not processor, between that the memory and processor. The instruction cycle is a very important part of that, I mean, for the computer system. We should have to understand this topic very carefully. It is actually going to be help us to understand that how the CPU is actually doing the operations in the computer system. So in that the newer version of the book, I mean, there is, I mean, you don't get this information anymore. This is a instruction cycle. This is a topic I have taken, I mean, maybe in older books, but it is a very nice information, very good information to understand actually how that the operations in the computer system is going to go on. So the instruction cycle, there are actually thousands of informations you can get in the Google about the instruction cycle. So here instruction cycle is known as the actually basic operation cycle of a computer system. So what is in the basic operation cycle we're having? In the basic operation cycle, there are 4 stages are going to be there. Okay, so that the CPU is going to be carried out. So what are those 4 stages of? We are having the fetching, we are having the decoding, we are having the executing, and we are having the storing. So these are the 4 steps that an instruction must need to be followed for completing an operation of the computer system. Okay, so so what these 4 stages are, let's say that it is talking about the fetching. So in case of fetching, it is talking about that returning a program instruction or data element from memory. So this is the part, that the part actually that the control unit of the processor, we have learned that there are 2 main components of the processor. One is the ALU, that arithmetic logic unit, another is the CU, the control unit. So the control unit of the processor is going to be fetch the data from the memory. Okay, so retrieving a program instruction or data element from memory. So this is going to be the fetching stage. Okay, that how the instructions are going to be fetched from the memory to the control unit. And the decoding part, decoding part, translating the instructions and data into a form that can be processed. So look at when the control unit is taking that the instructions from the memory, So when he is getting the instructions, he need to be translated. So many of us actually we confused that the translation is going to be done with the binary bits. Remember, when the instructions are into the computer system, they are already in binary form. Okay, so that is actually going to be decoded with a language that is actually the machine language, so that the ALU can understand it. So that is the next step actually. That I mean, after translating the instructions, the control unit is going to be sent it to the ALU. So that is the ALU. This the translation is going to be understood by the ALU. If the translation is not there, then ALU will not understand that what he is going to be do with that the instructions that has been brought from the memory. So here executing part, we can see here that carrying out the commands. So executing part is going to be do the executions. So that means the command it got from the CU that okay, what he has to do, that he is going to be execute on that the ALU. After doing the execution, the result will come out. After the calculations, the result will come out, and after that, that result is going to be sent to the memory back, RAM to RAM back. Okay, so that the result is going to be saved into that the memory. So these are the four very important stage. We are going to be see some of that future discussions. This instruction cycle is needed to understand. Otherwise, some other topics is not going to be understandable. So that is why you are getting here an example, very nice example to understand the instruction cycle. So here that we have said already that there are four steps, four stages. That is the fetch, that is the decode, that is the execute, and that is the store. So we are simply taking a form that we are saying that there we are having a memory. That means this is our RAM. Actually, memory means here that the RAM, without any doubt. This is our RAM. Okay. So from the RAM, we say this is our this is our microprocessor. This is our processor. This box is our processor, and inside the processor we are having the two main components. One is that the ALU and one is the CU. So in the first step, here what we are showing, like in this example, we are showing that how the instruction cycle will carries out with an instruction 3 plus 5. So that I mean how this 3 plus 5 instruction is going to be executed on the computer system to get the result 8. Okay, so yes, here we are using that the numbers with that real numbers, but here you should have to make sure that this is already translated. I mean, this is already translated into ASCII code. The numbers, the control unit is going to be fetched. That is already in ASCII format into that RAM. We are using here numbers, the solid numbers, because that I mean, to understand this example, that okay, how these operations are going to be go on. So the first step is the fetching stage. The fetching stage, the control unit retrieves the instructions 3 plus 5 from the memory. So the input you have given 3 plus 5, that is actually from addition, that is actually into the RAM. So the CU of the processor, the control unit of the processor, is going to be take, it's going to be fetch, it's going to be retrieve the instructions 3 plus 5 from the RAM to the control unit. So when the control unit, this is the first step, right? Fetching. The control unit retrieves the instructions 3 plus 5 from the memory. So now when that the instruction is going to be brought from that the memory to the control unit, that comes the second steps. So that the instruction it brought that 3 plus 5. So that is need to be translated. So it said the control unit translate the instructions to add 3 to 5. So that is what this translation is going to be need. Why? Because that the instructions you have bring that is going to be with the, again I'm telling, that is going to be with the binary format. So that the ASCII code format, the ALU does not understand this ASCII code format. So the control unit should need to be translate that ASCII code format such a way so that execution unit can understand that language. So that was what we are talking about. That okay, he knows English, he knows English. So he's telling that how are you? He said yes, I'm doing well. But he knows English, but he does not. He's using he knows Bangla, but I mean other the memory or controlling it, they know both Bangla and English, but he does not know English. Only he knows Bangla. So that means that English version instruction he has got from the memory to the CU. So that means it needs to be translated into Bangla. So that is what actually in this example, that from the memory that the 3 plus 5 instruction has been retrieved. That is in binary format. So that the binary format does not understand by that the ALU. I mean that the ASCII code format. So that need to be translated into that the machine language. Actually, that the language the ALU understand. So that is what that the 3 plus 5 instructions is going to be translated, and that the instruction is going to be add 3 to 5. So that is the language that the ALU will be able to understand, the add. Okay, so this is the machine language. Actually, it is going to be clear when we are going to be show the detail operations, the fetch, decode, execute operations into the processor lecture. So the add is actually that here that the machine language that is going to be understandable by the ALU. So that's why it is translated that the instructions 3 plus 5 are retrieved by the CU. So it is translating with that the machine language so that the ALU can understand it. So that after doing that the translation add 3 to 5, that instruction is going to be sent to that the ALU from the controller to the ALU. So what is the command the CU is sending to the ALU? Add 3 to 5. So that means now the ALU will understand that okay, the commands he has received add 3 to 5. By seeing that add, he will understand that I have to do the addition with that the 3 to 5. So that means he's going to be do this performance. He's going to be perform this operation, arithmetic operation. So that is he's going to be calculate that 3 plus 5 equals 8. So that the 8, the result he has got, the ALU got, that is going to be sent back to that the RAM, to send back to the memory. So this is what is showing that the fourth stage or fourth step, that is the storing. So it is telling the ALU sends the results 3 plus 5 8 to memory, and the memory is going to be store it. Okay, is it clear?
Yes, sir.
Yeah.
Yes, sir. Clear.
Yeah, so make sure that, I mean, this is the 4 steps. I mean, you're always remembering that fetch, decode, execute, and store. And you should have to remember that the control unit is fetching the instructions from the memory, that is with the ASCII format. But ALU does not understand the ASCII format, and that's why it needs to be translated into the machine language. Into that it should be translated the instructions with machine language that add 3 to 5 in this case. So that is going to be sent to the ALU, and then ALU will understand that okay, I have to do the operation for adding operation or addition operation for 3 to 5. So that is going to be execute that operation, and that the result 8 is going to be sent to the memory, and that is going to be stored into the memory. So here we are talking about the microprocessor chips. Yeah, so chips, chip capacities are expressed in word size. The word size, that is the key word, the word. Okay, the key word is word here. Chip capacity can be expressed in word size. So what is the word? A word is nothing but the number of bits that can be accessed at any time by the CPU. Okay, so that means the you are having that the more bigger word size. That means the CPU will be able to do the more complex operations, more operations at the same time. So the word here, the word size we are talking about, that is nothing but number of bits. Okay, the number of bits that the CPU can be able to execute at a time. So that is, it is telling that a word is the number of bits that can be accessed at one time by the CPU. Okay. So now here that we are talking about that the microprocessor chips. Yeah, there are 2 types of microprocessor chips, sir. What are they? One is the CSC chip, one is the RISC chip. So what is the CSC chip is? It is talking about CISC. So that is complex instruction set computer chips. So that by seeing the name of this chip, we can understand that okay, this type of chip is going to be deal with that the complex instruction set. Okay, so this is that the mostly used by the Intel. Actually, this the CISC chips is a very much older chip that I mean the CPU is actually carrying on with it. So the most widely used design, this is that the CISC chip is actually used for that long time. That is with the CPU. So what is actually the CISC? I have already said you that what is chip is. I already said you that a chip is actually given some of the instructions so that I mean anything going to be happen, any command it gets, he will actually going to be work according to the instructions. Like in the yesterday last class we have actually discussed that okay, what I know, what human know, that he is going to be give the response automatically, that he knows the language, or he is asked something, he is just listening it and he's going to be give the answer. So if it is asking something to a human he does not know about, then he will not be able to answer it. He's going to be quiet. He will not be have the answer. So that the chips are also same, that it is going to be given some instructions, so that the instructions are there under the chip. Only on that instruction he will be able to answer. He'll be able to work on. But something else, if it is trying to give you are trying to give to him, he'll not be able to understand. So then the chips are there. This is the chip. So what actually is happening? That a chipset are getting some instructions, so that if I'm saying that this is the box of instructions he is going to be received. So they are the bits are going to be here. It can be that say that 1000 bits together it's receiving for a program. Okay, so that 1000 instructions are going to be taken at a time. If he is receiving 100, if he is receiving the 200 instructions, if he is receiving the 400 instructions, right, it does not matter. I mean, he is going to be consider all those instructions as a single instance. He is going to be consider all the instructions at a time. So that is why it's complex. That is why it is going to be known as the complex instruction set. So this is going to be difficult to work with. That okay, if I'm having this much as that instructions are coming together. So that is what the later on the RISC chips actually has been introduced. What is that? Reduced instruction set computer chips. So that is the reduced instruction set. By seeing the name, you can understand that it has actually taken that the consideration of the 6 chips. It was complex, and he's telling that I'm going to be reduced the instruction set. So what is going to be there? It is saying that it uses fewer instructions. So it's when that the RISC chips is going to be introduced, it does not mean that you are going to be avoid the 6 chips. Why? Because this is the CSC chips you are using for the long time. The language is with you. The instructions are with you. So if you're not using those instructions, if you're trying to give that the other instructions to the computer system, then definitely that your older programs are not going to be run. So it is something like that. I mean, human also, that the language we have learned Bengali. So even though we are learning that 10 languages, 20 languages, but still the Bengali language is going to be with me, with us, and not going to be lost it. So that is what the computer also should not lose that the previous instruction set. So what actually the RISC chips is doing is, the RISC chips, it is simply that, I mean, it is the set of instructions. We say that instruction set is going to be coming to the 6 chips. So from that, the 6 chips, that the set of instructions are there. If there is 1000 instructions, maybe there are going to be the 10 frames. There are going to be the 10 frames which are going to be having 100. So that means 100 into 10. It is going to be 100 into 10. It is going to be 1000. So that is what that I mean. He is reducing the instruction set. So to get total number of instructions are going to be divided into the smaller sizes of frame, so that the frame one by one is going to be executed on the CPU. Okay. So if it is done, then there is going to be easy for the CPU, that it is going to be easy to deal with these instructions. But if you're giving him that a lot of instructions at a time to the CPU, then definitely it is going to be difficult for him to do the works. Like for the human being, if if I'm taking your exam, and in the exam, if I'm giving you the 100 questions and giving you 1 hour time, maybe that the questions are not, maybe question answers can be given in 3 hours, but I'm giving you that 100 questions, and I'm asking to finish it 1 hour. So it is going to be very difficult for you to actually touch on those all questions answers, because you have not given you are not have given the more time, and you have to answer that so many questions. So it is going to be difficult. Maybe you'll be able to touch all that the question answers, some of you, but most of the students are going to be not. It can happen that none of you are going to be touched on that all the questions. So this is what. But if it has been given that okay, you give that out of 100 questions, you are going to be given the 4 hours. For each 25 questions, you are going to be given the 1 hour. Then actually you're going to get that 1 hour by 1 hour. So you'll be able to concentrate all these questions, and you'll be able to answer them. So this is what I mean. This that the RISC chips, what it is doing, it is actually taking that all the instructions together, and after that it is breaking that instructions according to the group, according to the frame. So it is making the smaller frame. Like that, you are doing the CSC 347 course. So there are maybe 7, 8 sections, so that all the students can be placed into that the same class. But it's not that each of the class are having maybe 45 to 50 students. So that each of the sections are dealing with that the different instructors. Why? Because it's not possible that okay, if there are say that 400 students for a course, that the 400 students you are going to be placed in a single class. It is not going to be possible by a teacher to control that the 400 students in a class, in a section. So that is what I mean. You are making a smaller size section. So this is also same. The RISC chips actually does. It is actually reduce the instructions. It group the instructions frame by frame, section by section, so that the CPU can take one by one and execute it simply. So that is what I mean. The RISC chip is actually RISC chip. When it comes, it is actually making that the CPUs to comfortable to work with the instructions. So design is simpler and less costly, and used by the power PC. So a RISC chip is produced by the Motorola. So what is happening here, that these CISC and RISC chips are actually combinedly used later on. Okay, so not only the CISC but also the RISC. So both of the chips are going to be there, and for tackling the instructions. So CISC chips is taking the instructions, and then it is going to be grouped by the RISC chips, and then it is going to be actually executable by the processor frame by frame or group by group or section by section. Is it clear?
Yes, sir.
Yes, sir.
Okay, so here we are getting that the specially processor. So yes, so that is what I was asking in a one class, that how many processor a computer is having. Do you know? If I'm asking you that how many processor your computer has,
Isn't that on?
isn't that one? So most of the question, how about the others? It's one or more.
One, sir.
One, sir.
Yeah, so we know that our computer system, we are having that one CPU, one central processing unit. But if I'm asking you that how many processor you are having, the answer is wrong. The answer is wrong, because there can be the several processing unit into your computer system. There can be the several processing unit into your computer system. Okay, so we call that the central processing unit. The reason is that this processing unit is the central of the computer system. That means this processing unit is going to be deal all of the operations into the computer system. But this is not going to be the only processing unit into that your computer system. Okay, so there can be several processing unit into your computer system. Like that, the graphics card, that yesterday we have seen that in the graphics card you will be see that there is a fan, that is a heat sink. Okay, So on that, I mean, the fan has been given, that the heat sink has been given. That is actually on the top of the processing unit. That is actually GPU, the graphical processing unit. So this is actually, there are some of the specialty processor can be there. It is there actually into the computer system. Not only that the central processing unit, but there are some other processing unit into your microcomputer. So that is actually, that those are the processing unit are for the special purposes. Okay, so that is, those special purposes processor or processing unit is known as the specialty processor. Okay.
Yes, sir.
So let's see that. I mean, we can see that some of the processors we are having here that are known as the specialty processor. Let's see that the co-processor first. So this is designed to improve the specific computing operations. So what does the specific computing operations we are talking about? That is actually the maybe for graphical purposes, right? So it is most widely used in graphics co-processor called the GPU, the graphical processing unit. So this is that the NVIDIA GeForce. This is actually GPU, the graphical processing unit. Okay, so actually why we need this GPU? Because day by day that the graphical works we are doing, that is actually mostly focused on 3D graphics or above. Okay, so that is why you need the better performance from your graphics card. So that means there are going to be a lot of millions or billions of calculations are needed, complex calculations are needed. So that is not going to be handled by that the graphics card you are having. You must need to be some processing unit that who is going to be control that those complex calculations. So that's why this processing unit is needed with that the graphics card, so that those complex calculations can be easily done. So this is one of the processor, the co-processor, that is actually known as the specialty processor. And actually, if you are having an external graphics card into your computer system, that means you are having a GPU on it these days. So the parallel processing, the parallel processors are known as the also specialty processors. So what does the parallel processor does? To run or process larger programs. Okay, break the programs into parts and assign the parts to the separate processor. So this is what the larger program we are talking about. We know that in our microprocessor these days we are having the multiple core. It can be 2 dual processor, it can be 4, it can be 8, right? So there are multiple cores into the single microprocessor. So that means as you are having that more than one core, so that means you are going to be, if the computers are getting a large number of programs, it will give that the works parallelly to that the different cores. So at the same time that the microprocessor, if there are 4 cores are there, that means 4 works at the same time can be possibly done. So that is the parallel processor. That is actually the parallel is going to be done. So this is what the example I have given for the library. So if the 50 students are going, single library man is there. So 51 by 1 students are going to be give the service. So it is going to be take time to take to get the service from the library man. But if I am having the 2 library men, then that automatically the 2 queues are going to be there. 25, 25. 25, 25. If there are 5 library men, then only 10 by 10, right? 10 by the queues are going to be the 10 by 10. So it is going to be very quick service. So that is that the parallelly actually work is going to be distributed. So think that inside the microprocessor you are having the 4 cores. The more cores you are having, so that means more quick access is going to be done by the CPU. Do you understand that parallel processor?
Yes, sir.
Okay. So the next thing is actually the quite interesting thing, that is the smart card processors. So this is the smart card processors are these are the it is known as the intelligent smart cards, contain a microprocessor with input, output, and storage capabilities. Memory cards have only storage capabilities. So here that the ID card you are having, that the student ID card of IOBAT, that the ID card is actually not smart, right? It is having that, but it is that the identifications of you is an unique identification that okay, you are the student of the IOBAT. So but in the same card, that the card can be made smart. As I already said maybe to your class, that what do you understand by the smartphone? I say to you that it is smart because it has that the many accessibility. It can work actually many tasks. With a single smartphone, we'll be able to do many tasks at the mobile phone. We'll be able to call someone. We'll be able to send SMS someone. We're going to be able to browse the internet. We'll be able to watch something. You'll be able to listen song. We'll be able to play games. So we'll be able to take the pictures, take the videos. So we can actually do a lot of activities by a single device. That's why we are calling it smart. So that the smart card we are talking about. So that means the card is going to be have the multiple what capability to work with the multiple activities. So this is quite an interesting thing. Like that, I mean, with that the card you are having. So that the card you are having with that the card a microprocessor chip can be given. So like that, I mean, you can have a bank account. I mean, so that with a bank account, you are using that the ATM machine card. So that your student card, that the chip can be given, microprocessor chip can be given. So that card you will not be able to only use for your university, but also this is going to be usable into your ATM machine for withdrawing the money or transferring the money from your account to the other accounts. Or if you're in the IOBT, if there is a say that I mean all the part like the main gate there is a automatic device is there. So that I mean there should need do not need to be have that any gateman. Simply that is going to be auto lock, and when you are pressing that pressing your card on the device, the door is going to be open. Maybe there is going to be some camera to check you that okay you are the already registered person or not. If the registered person, it is going to be allowed you to enter, otherwise not. So your lab, that the lab you are having, that the lab can be locked automatically. So you have the class on the lab, so you will be touched that the card the device is going to be automatically checked that okay you are the registered person for this class or not. If this registered person you are, then that the door is going to be open, otherwise not. So similarly, that it can be done. I mean, this card can be used for many other activities. So that is why the card is actually going to be considered the smart card, because with this card, it is going to be your identification that you are a university student. In this card, you will be able to enter into that your university. You'll be able to enter into your department. You'll be able to enter into your lab, computer labs. You'll be able to withdraw some money from the ATM machine. You'll be able to do some shoppings into that the shopping mall. You can use it as a debit card for internet shopping. So look that a single card has that the many varieties of accessibility. So that is actually that known as a smart card. Okay, so that is what I mean. We do not have, unfortunately, till now in any university we do not have any smart card. But in abroad, if you are going, most of the universities ID cards are actually smart. I have used the card. I mean, for when I was in South Korea for 8 years. For the long 8 years, I have used that the same card, that the smart card. With that single card, even you know that I mean they have that the communication school, they have that the electrical school. So this is a very, very big campus, and every departments are separated. Every department buildings are separated. So if you are a student of the CSC department, you will be able to only enter into the CSC department building. Your card is not going to be supported in any other buildings. So this is how they are making that a secured place, a secured environment for each of the department, each of the university. Do you understand that? I mean, how interesting it is. Then how I mean smartly that the things can be tackled. Get it? The smart card processor.
Yes, sir. Got it.
Yes, sir.
Right.
Yes, sir.
Sir.
Yeah.
Hello, sir. Sir, I have a question, sir, about
Yes.
motherboard, sir.
Yeah, sure.
There are some motherboard. Previously, my motherboard have two pin with cap. But when we are, I don't know about this cap. Somehow I removed this cap, and my computer is full. Okay, my processor, power supply, everything is okay. But my display is not working. So, which reason for that? And this my display is not working.
You have removed some jumpers, you mean? The like cap you said, maybe these are the
Yes,
jumpers.
two pin cap
Two
in the
pin,
corner
right.
of motherboard. Yes,
Right. So two pin cam. So that means this is actually that the jumper. We call it actually the jumper. Okay. So this that there are several jumpers are there with that actually you can control that your different things. Like I think that the jumper you have removed, that is actually the BIOS jumper. Okay, CMOS setups. So
yes.
maybe that, I mean, when you are placing that the jumper onto that the board, I think that you are selecting the wrong pin. Okay, so check with that.
No,
I mean, there
no,
are,
sir, no, sir, no, sir. There
yeah.
is everything okay. Just only two pin. There is a two pin cap. Only two pin cap is removed. Then my display is not working. My
So you
monitor
just, I
is
mean,
working.
what I'm saying is that you have removed that cap, so you just install that cap again and then start your computer. It's
Yes,
going to work.
yes. My computer is working, but display not working.
So that you have some the connection problem for your monitor. Check it properly, and it is there or
No, sir.
not.
Then I'm talking with specialist of CPU. Then he tell me this cap only for this cap. Our display is not working.
No, no, no. There is the caps are there. You're talking about that is actually the jumper. In that the computer hardware language, we call it jumpers. Okay, so there are several jumpers are there on the onto the board. I do not know that actually which jumper you have removed. So that the jumper you have removed. So you, I understand that why you have removed it. Now I understand that you have some display problem, and that's why you have removed that jumper. And you're thinking that now your display is going to be okay. Is it?
No, sir. I'm every time I'm working with my motherboard, I'm adjusting RAM or something else, SD card. Then somehow I'm removing this cap, but I don't know this cap is necessary for motherboard. Then when I'm turn on my computer, but my computer is full okay, turn on, that's full okay. My monitor is okay, just display is not working. Then I am tell with mechanic. Then he tell me just for this pin
Mechanic gold
your
var.
display is not
Güzel.
showing.
Working. So did that I'm asking that did you, I mean, you have opened that the jumper, did you install that the jumper again onto your motherboard or
Yes,
not?
yes, sir. Yes,
So
sir.
after installing that your monitor is okay or not?
Okay, sir. Everything was okay.
Right. So that is what I'm saying, that I mean that the jumpers, it can be used for the different purposes. So if you're removing a jumper, that means it is going to be of course it is going to be effect on your computer system, right? So there are several jumpers are there, maybe three, four, it can be. For the
If
CMOS setup, you're having a jumper as well. Okay.
if
So what is your question? What is your question? I did not get it.
why motherboard have used to this type of pin? Why? Which
Yeah, you
reason?
know that. I mean, these that the two pin connectors are there for making something on. So if that the electricity pass on these two pins, that the several things can be on. There can be several things can be locked. There are several things can be open. There are several things can be on. Do you understand that? So why it has been why it has been actually that the two pin has been given and why actually this jumper is controlling the display so that the information you are going to be get from this manual. There is an explanation for this, but I do not know about this the display pin, but I know that there is a pins, two pins are there that with that actually CMOS setup can be controlled. So that I mean, for example, someone is locking the computer with that the CMOS password. Then if you do not know that the password, but if you want to open the computer, then if you are removing that the jumper and wait for 30 seconds and installing that the jumper again, then your computer system actually is going to be that the CMOS is going to become default. So that means the CMOS password is automatically going to be removed. Okay. So this is that the different settings are there. Like the previous time we are having that the hard disk. So that the hard disk data can be read, hard disk data can be write, or hard disk data can be read and write both. Or hard disk data is going to be locked. So there are some several pins are there, two pins with the jumpers actually used to control. But these days actually it is not here. So that is what that the jumpers are going to be used for the different purposes. Even like that the start button you are pressing into your computer system. right? That is also coming with the 2-pin connector. Okay, so if you are removing that and if you are trying to pressing that the button, it is not going to be work because it is not getting that the command that start. Get it or not? But if you are removing this 2 point and using a tester, for the start button, the 2 pins you are connecting with your motherboard. So if you are removing that and you are after giving supplying the current, if you are just using a tester for connecting the 2 pin, your computer is going to be start up. Get it or not? So that is that the functionality of some of the devices, functionality of some of the portions is going to be controlled by the 2 pin. Get it or not?
Yes, sir. Yes, sir.
So that is that the reason that actually when you have removed that the jumper, so that connection is not getting, and that's why your display is not working, and that your display is completely going to be based on that your graphical performance of the PC. Maybe that if this is the jumper is controlling that the graphics part. So if you're not giving that the graphics part on, if you're not making the graphics part on, that means your display is not going to be get. Do you understand it or not?
Yes, sir. Yes, sir.
Maybe that this is going to be the reason what I understood. Okay.
Yes, sir.
Okay. So here we are talking about that the memory. Thank you, Mizanur. So here we are going to be talking about that the memory. So that the memory you are talking about, you have already said that the memory is a place where you can store the data, instructions, and information. So it is all going to be hold that the data, instructions, or information. We have already discussed it. Memory is content on chips connected to the system board, right? So there are different types of memories are actually are there into our computer system. So that most importantly that the RAM that we can see that we are installing into that the memory slots or RAM slots. So that the RAM we are not that the RAM we are having as a memory into our computer system. There are some other memory chips are there like that the ROM and CMOS we are talking about. So if anybody is asking to you that what are the types of memory chips? I mean, how many? What are the number of chips? Different types of. Can you please tell me the different types of memory chips? So with that, the memory, if this word has been used, chips, then that means you should have to tell that there are different types of chips, like that the RAM chip, like that the ROM chip, like that the CMOS chip. It is asking to you that okay, discuss about the two types of memory. Or types of memory, basic types of memory, then it is going to be the two types of basic types of memory, that is the main memory and secondary memory. But if it is asking to you that explain the types of memory chips, that means this is that it is asking about that what are the different type of memory chips are available. So on that case, it is going to be RAM, ROM, and CMOS. Clear?
Yes, sir.
So the RAM is here for holds the data programs and data. So that we have already discussed. The ROM is there for fixed startup instructions, and the CMOS is there flexible startup instructions. So this is the difference, main difference between these three chips, the RAM, ROM, and CMOS. What are the difference? That RAM is going to be holds the active data and program. ROM is going to be hold the fixed startup instructions, and the CMOS is going to be have the fixed startup flexible startup instructions. So these are the main keywords for this of these three chips. So we are going to be discuss these three chips, memory chips, one by one, maybe with a bit more detail. So here we have already said about the RAM, the random access memory, and that is going to be actually installed into the RAM slot. The random access memory chips holds the program active data and program actually, and it has the three basic types of RAM. So we are having that dynamic RAM, we are having the static RAM, we are having the flash RAM or flash memory. So all these three types of data. So this is actually the dynamic RAM we are talking about, static RAM we are talking about. So these are the two RAMs we are going to be discuss in detail into our main memory lecture in future. I mean in this course. And there is also the flash memory, or that is the flash memory is that kind of a memory that is going to be used actually that the different technologies. So we are going to be actually talk about these RAMs one by one. I mean we are going to be see a brief ideas here on. It is coming after this example. So it is showing here that how RAM stores the instruction and result for 3 plus 5. So we have taken this example, these instructions 3 plus 5 for the 3 or 4 examples. So you should have to study these 4 examples by drawing the figures. And actually they are I mean very much important. They are actually relevant one to another. Okay, so here it is telling here that how RAM stores the instruction and result for 3 plus 5. So we have seen that how the basic instruction cycles are worked in this today's class that we have seen that it is fetching from the memory, C is fetching from the memory, C is decoding the instructions, C is giving that to the ALU executing it and sending the result to memory and memory storing. So that is what well that the instructions in the memory. Okay, so how that the memory is storing that instructions, and when it has been gone to CU, ALU and come back to the memory, how the result is going to be stored. So that is actually it is trying to show to you here. So here, supposing this is the block you're saying that this is actually your RAM. So the RAM size can be different, but based on that the RAM size, you are going to be have some blocks of the RAM. So each of the blocks are going to be have some address. Say that this block address is M1, then M2, M3, M4, and dot dot dot. So that means M1 to MN. So there are the different blocks are going to be there, different locations are going to be there. On that the locations you are going to be stored these instructions. So now that the same example 3 plus 5 we are taking, so that the 3 plus 5 is already in the memory that we have seen in the instructions. So that the 3 is actually stored, for example, into that the address M1. So that what is that the ASCII code of 3 that is actually just written here. So for the plus operator, what is the ASCII code that is written into that the M2. So this is at the location the plus operator has been stored on the memory, on the RAM. And that the 5, what is the ASCII code? The ASCII code of the 5 is actually stored into the location of address M3 in the memory block. So this is actually ASCII code for 5 has been stored. So these are the three instructions are stored into these 3 different locations. So now that actually the control unit of the processor is fetching these 3 instructions from the memory from the location number M1, M2, and M3. So when that is going to be decoded and it is going to be sent to that the ALU, so ALU is going to be make the executions and it is going to be sent back the result to the memory. So that the result is going to be stored into that the, for example, the address 4. So you can see that 3 plus 5 equals 8, that the ASCII code of 8 is actually storing into the location, new location address M4. Do you understand that?
Yes, sir.
Okay, so now here we are having that the DRAM. So we are actually showing only that the examples here that okay the DRAMs, the dynamic RAMs, it is actually cheaper than that the SRAM that we are having because of the technology. So we are going to be study that SRAM and DRAM in detail, and we are going to be see that actually design of SRAM it is actually complex and it needs actually some of the special components that makes the SRAM expensive. But here we are actually mainly focusing on the capacitors in case of the dynamic RAM, and that is actually is going to be price is going to be reduced because of that the less components are required for the dynamic RAM compared to the static RAM. So that is what actually the DRAM comes out, and that's why in the main computer main memory we are using the DRAM. We are installing the DRAM into our memory slot. So if we could actually use the static RAM, then our computer could be actually much faster. But the problem is that static RAM is very expensive, and that's why it is not using as the main memory that what we are installing into that memory slot. Okay, so this is what the DRAM, the different DRAM we can see here that are the like the synchronous DRAM that we call the SDRAM, the double data rate SDRAM, direct RAM bus SDRAM. So in the market that the RAMs are actually coming with that every day actually this maybe every duration of time that the RAMs are actually updating. So there are different types of DRAMs are coming into that now you know that we are having the double data rate as DRAM, the DDR RAM. So the DDR RAM 1, 2, 3, 4. So it is continuing that actually to updation of the RAMs. So the RAM space is also increasing. It is getting more faster, and so on. So this is what out of these 3 RAMs, the direct RAM bus is actually the most expensive one. So okay, so we are finishing our lecture. The time is up. So we are going to be start the next lecture from the slide number 34. Okay, remember it. Okay, then thank you very much. And do you have any questions? If you have any questions, you can ask. Otherwise, the class can be done. Finish. Thank you. You can take care.
Thank you, sir.
Assalamualaikum.
Walaikum assalam. Please take care, all of you.
Assalamualaikum, sir.
Thank you.